Hello students, today we are going to see a lecture on machining and machining tools, general purpose and special purpose machine tools that which include lathe, accessories, attachments, training and related operations. My name is M.Gobi, Assistant Professor Mechining. So overview of the machining tools. Machine tools, we are going to discuss about machine tools concept and functions, machine tools classification and types, lathe and turning, lathe operations, construction, attachments and accessories. So machine tools, we will discuss here about what is machine tools. The definition of machine tools is a machine tool is a non-portable power operated and a reasonably valued device or a system of devices in which energy is expanded to produce jobs of desired size, shape and surface finish by removing excess material from the preformed blanks in the form of chips with the help of cutting tools moved past the work surfaces. So we will discuss about the functions of machine tools. Machine tools produce desired geometrical surfaces on solid bodies, preformed blanks, and for that they are basically comprised of devices for family holding the tool and work, drives for providing power and motions to the tool and work, kinematic system to transmit motion and power from the sources to the tool work, automation and control systems including control systems for machining parameters like speed, feed and depth of cut, structural body to support and accommodate these systems with sufficient strength and rigidity. So the next one is we will discuss about tool work motions. Various shapes are governed by movements of generatrix and directrix. For machining flat or curved surfaces, the machine tools need relative tool work motions, which are categorized in following two groups. Formative motions, namely cutting motion, feed motion, the auxiliary motions such as indexing motion, additional feed motion and relieving motion. So machine tool drives. For the desired tool work motions with power, machine tools are driven by electric motors and use of some mechanisms like belt, pulley, gears, etc. In some machine tools, the tool work motions are provided by hydraulic drive also. Machine tools essentially need wide ranges of cutting speed and feed rate to enable machining different jobs of different materials and sizes using different cutting tools, different material geometry and size, various machining operations like high speed turning to low speed thread cutting in lathes, and degree of surface finish desired. So here we will discuss about machine tool drives, that is types of machine tool drives. Stepped drive, common in conventional machine tools where a discrete number of speeds and feeds are available and preferably in geometric progression series. Stepped drive is attained by using gearboxes or cone pulley, which is an old method, along with power source. Stepless drive. Modern CNC machine tools are provided with stepless drives, enabling optimum selection and flexibly automatic control of the speeds and feeds. Stepless drive is accomplished usually by variable speed AC or DC motors, stepper or servo motors, and hydraulic power jack. Now we will discuss about the broad classification of machine tools. According to direction of major axis, machine tools are divided as horizontal machine tools, vertical and inclined. We will discuss about each of these. Horizontal machine tool, example center lathe, horizontal boring machine. Vertical machine tools, vertical lathe, vertical axis milling machine, etc. Inclined machine tools, example is special purpose machines for transfer machines. According to purpose of use, we classify the machine tools as general purpose, example center lathes, milling machines, drilling machines, etc. Single purpose machine tools, example is facing lathe, roll, turning lathe, etc. and special purpose machines for mass production. According to degree of automation, non-automatic, example center lathes, drilling machines, etc. Semi-automatic, example is capstan lathe, turret lathe, etc. And automatic machine tools, example is single spindle automatic lathe, Swiss type automatic lathe, CNC milling machine, etc. Now we will see about the broad classification of machine tools. According to size, heavy duty, example heavy duty lathes, above which consume electricity above 555 kilowatt, boring mills, planing machine, horizontal boring machine, etc. Medium duty, example lathes 3.7 to 11 kilowatt, column drilling machines, milling machines, etc. Small duty machine tools, example tabletop lathes, drilling machines, milling machines. Micro duty machine tools, example micro drilling machine, etc. According to precision, machine tools are classified as ordinary and high precision. Automatic lathes are example for ordinary machine tools, and high precision machine tools example is Swiss type automatic lathes. According to number of spindles, machine tools are classified as single spindle and multi-spindle. Example for single spindle machine tool is center lathes, capstan lathes, milling machines, etc. Example for multi-spindle is multi-spindle lathes, gang drilling machines, etc. Broad classification of machine tools. According to blank type, machine tools are classified as bar type, chucking type, and housing type. According to type of automation, they are classified as fixed automation, lathes, flexible automation, etc. According to configuration, they are classified as standalone type, machining system, power drive with speed and feed change mechanisms. Now we will discuss about tanning and related operations. Tanning. Part is rotated while it is being machined. Axisymmetric jobs are produced. Starting material is generally a workpiece made by other processes such as casting, forging, extrusion, drawing, or powder metallurgy. Lathe working principle. Workpiece held between two rigid and strong supports called centers or in a chuck or faceplate which revolves. The cutting tool is rigidly held and supported in a tool post which is fed against the revolving work. Cutting tool removes metal in the form of chips by shear action. The normal cutting operations are performed with the cutting tool fed either parallel or at right angles to the axis of the work. The cutting tool may also be fed at an angle relative to the axis of the work for machining tapers and angles. Here it is, this diagram explains the cutting tool motion. Tanning processes. To produce straight, conical, curved or glued workpieces such as shafts, spindles and pins. In this process, the tool is fed along the axis of the spindle. Tanning is the removal of metal from the outer diameter of a rotating cylindrical workpiece. These figures represent the straight tanning, taper tanning, profiling, and tanning and external grooving operations. Facing. To produce a flat surface at the end of the part and perpendicular to its axis. Useful for parts that are assembled with other components. Face grooving produces grooves for applications such as O-ring seats. Cutting with form tools to produce various axisymmetric shapes for functional or aesthetic purposes. Boring is used to enlarge a hole or cylindrical cavity made by a previous process or to produce circular internal grooves. Drilling is used to produce a hole which may be followed by boring to improve its dimensional accuracy and surface finish. Parting is also called as cutting off, to cut a piece from the end of a part as is done in the production of slugs or blanks for additional processing into discrete products. Now we will see about threading. Threading is nothing but it is used to produce external or internal threads. Knurling is used to produce a regularly shaped roughness on cylindrical surfaces, as in making knobs and handles. Operations on lathe detail. Straight tanning. The work is tanned straight when it is made to rotate about the lathe axis and the tool is fed parallel to the lathe axis. The straight tanning produces a cylindrical surface by removing excess metal from the workpieces. The diagram indicates the movement of the tool relative to the workpiece. Solder tanning or step tanning, process of tanning different surfaces having different diameters. The work is held between centers and the tool is moved parallel to the axis of the lathe. It is also called solder tanning. Taper and taper angle. A taper may be defined as an uniform increase or decrease in diameter of a piece of work measured along its length. So in taper tanning, the angle is determined as tan alpha equal to d minus d by 2l and alpha equal to tan inverse of b minus d by 2l, where d is the large diameter of taper in mm, small d is the smaller diameter of taper in mm, capital L is the length of the tapered part in mm, and alpha equal to half of the taper angle. The conicity k of a taper is defined as k equal to 2 tan alpha equal to capital D minus small d divided by L. Taper tanning. An operation performed on a lathe that feeds a tool at an angle to the length of the workpiece in order to create a conical shape or gradual reduction in diameter. There are 4 methods. Tailstock set-over method, by swiveling the compound rest method, taper tanning attachment method, form tool method. All these methods are discussed in detail. Tailstock set-over method of taper tanning. This method is used for small tapers only, the amount of set-over being limited. It is based upon the principle of shifting the axis of rotation of the workpiece at an angle to the axis and feeding the tool parallel to the lathe axis. The angle at which the axis of rotation of the workpiece is shifted is equal to half angle of taper. This is done when the body of the tailstock is made to slide on its base towards or away from the operator by a set-over screw as shown in figure. The figure details about the tailstock set-over method of taper tanning. The tailstock is moved away from its center position. Tailstock set-over method of taper tanning again. By setting tailstock center to the back away from the operator, the taper will have bigger diameter towards the tailstock. If the tailstock center is taken in the front, bigger diameter will be on the headstock side. The reduction in diameter will be twice the offset of tailstock center if entire length is strained. The major disadvantage of this method is that the live and dead centers are not equally stressed and the wear is non-uniform. Also, the lathe carrier being set at an angle, the angular velocity of the work is not constant. It is useful for tanning very long tapers up to 5 degrees. This method should be avoided if possible. Calculation of set-over. The amount of set-over required may be calculated as follows. From the right-angled triangle M and P, we have NP equal to set-over, S equal to Mn sin alpha equal to Lj sin alpha. For a very small angle, it can be safely considered that sin alpha equal to tan alpha. That is set-over S equal to Lj tan alpha, or S is equal to Lj into capital D minus small d divided by 2L in mm, or S equal to total length of job or work into total taper divided by 2 into taper length, where S equal to the required set-over in mm, capital D equal to larger diameter in mm, small d equal to smaller diameter in mm, Lj equal to total length of job or work in mm, and capital L equal to length of tapered portion in mm. In case the job is to be tapered over its full length, L will be equal to Lj. Therefore, the set-over will be given by capital S equal to capital D minus small d divided by 2 equal to total taper divided by 2. The amount of the offset required may be quite accurately set by allowing the tool post to touch the tailstock barrel in the normal and in the offset position. This is accomplished by turning the cross-lead screw when the offset is measured directly by the difference of readings on the micrometer dial. A more accurate reading is obtained by using a dial indicator in conjunction with the cross-lead. For accurately setting of this tail star, slip gauges are sometimes used. Spiraling the compound rest method of taper tanning. It is the best method as it does not affect the centering of the job or centers. In this method of taper tanning, the workpiece is rotated on a lathe axis and the tool is fed at an angle to the axis of rotation of the workpiece. The tool mounted on the compound rest is attached to the circular base, graduated in degrees, which may be swiveled and clamped at any desired angle as shown in figure. After the compound rest is set at the desired half taper angle, rotation of the compound slit screw will cause the tool to be fed at that angle and generate a corresponding taper. Tan alpha or alpha equal to tan inverse of capital D minus small d divided by 2L. The figure describes the swiveling the compound rest method of taper tanning. Owing to the limited movement of the cross slide, this method is limited to tan to short taper. A small taper may also be tanned. Short lengths of tapers not exceeding 45 degrees included angle are usually tanned by this method. This method gives a low production capacity and poor surface finish because the movement of the tool is completely controlled by hand. This method is tiring if the transverse length is lengthy. The figure shows the taper tanning attachment method of taper tanning. This method provides a very wide range of taper. In this method of taper tanning, a tool is guided in a straight path set at an angle to the axis of rotation of the workpiece, while the work is being revolved between centers or by a chuck aligned to the lathe axis. As shown in figure, a taper tanning attachment essentially consists of a bracket or frame which is attached to the rear end of the lathe bed and supports a guide bar pivoted at the center. The bar is provided with graduations and may be swiveled on either side of the zero graduation and is set at the desired angle with the lathe axis. The taper tanning attachment is used as follows. The cross slide is first made free of the lead screw by removing the binder screw. The rear end of the cross slide is then tightened with the guide block by means of a bolt. On the engagement of the longitudinal field, the tool mounted on the cross slide will follow the angular path as the guide block slides on the guide bar set at an angle to the both axes. The required depth of cut is given by the compound slide which is placed at right angles to the axis of the lathe. The guide bar must be set at a half taper angle and the taper on the work must be converted in degrees. The maximum angle through which the guide bar may be swiveled is 10 degrees to 12 degrees on either side of the center line. After every cut, the feed to the tool is given by moving the compound rest which is positioned parallel to the cross line. The required angle can be found out from the following relation. Tan alpha equal to capital D minus small d by 2L. Alpha equal to tan inverse of capital D minus small d divided by 2L. Advantages of using taper tanning attachment. It is very easy and quick setting. The operator may not be highly skilled. Accurate tapers can be easily obtained in a single setting. Very steep taper on a long workpiece may be tanned, which is not possible with any other method. The next one is form tool method of taper tanning. In this method of taper tanning, a broad nose tool having straight cutting edge is set on to the work at the half taper angle and is fed straight into the work to generate a tapered surface. With this method, tapers of short length only can be tanned. This example is a numerical example. So the formula used for taper is D minus D by L. Taper in millimeter equal to, you divide the meter by 1000, then you get the millimeter. The angle to which the compound rest should be set up, alpha equal to 5.7 degrees. The next one is chamfering operation. Operation of beveling the extreme end of workpiece. For removing burrs to protect the end of the workpiece from being damaged and to have a better look. It is essential before thread cutting so that the nut may pass freely on the threaded workpiece. Next one is eccentric tanning. If a cylindrical workpiece has two separate axes of rotating, one being out of center to the other, the workpiece is termed as eccentric, and tanning of different surfaces of the workpiece is known as eccentric tanning. The distance between the axes is known as offset. If the offset between the centers is small, two sets of centers are marked on the faces of the work. The work is held and rotated between each set of centers to machine the eccentric surfaces. For more offset distance, special machines are used. Next one is facing. Facing is the process of making flat surfaces analyzed. The job is held on a face plate or chuck and the tool is fit at right angles to the bed to obtain flat surfaces. Using a forge or chuck, you can face rectangular or odd-shaped work to form cubes and other non-cylindrical shapes. Forming is an operation on a lathe. A forming tool having cutting edges conforming to the shape required is fed straight into the work for obtaining a convex, concave or any irregular shape. Filling, finishing operation that removes burrs, sharp corners and feed marks from the workpiece. Grooving or recessing or linking, cutting a narrow groove on the cylindrical surface, often done at the end of the thread or adjacent to a shoulder to leave a margin. The groove may be square, radial or beveled in shape. Knurling is a process of embossing a diamond-shaped pattern on the surface of a workpiece by making a series of indentations or depressions. The knurling tool holder has one or two hardened steel rollers with edges of required pattern. The tool holder is pressed against the rotating work. Knurls are available in coarse, medium and fine pitches to provide an effective gripping surface, better appearance, to slightly increase the diameter of the work. The next one is spinning, also known as spin forming or spinning or metal tanning. A disc or tube of metal is rotated at a high speed and formed into an axially symmetric part. This process is covered in detail in sheet metal forming processes. Spring winding, method of springs winding performed on lathe, not in our scope to discuss because it is a very advanced topic. Undercutting, done at the end of a hole, near the shoulder of stepped cylindrical surfaces, at the end of the threaded portion in bolts, enlarging the diameter if done internally and reducing the diameter if done externally over a short length. Parting off. The parting or cutting off is the operation of cutting away a desired length of the workpiece, that is, dividing the workpiece in two or more parts. Drilling. Making holes generally in the center of workpiece with the help of drills. The drill is held in the tailstock and the drilling operation is carried out by advancing the drill in the workpiece by rotating the handle of the tailstock. Reaming. Process of enlarging holes to accurate sizes, always carried out after drilling. Similar to drilling reamer is held in tailstock. Two broad categories, hand reamers and machine reamers are used. Boring is the operation of enlarging a hole produced by drilling, casting, punching or forging with the help of a single point tool. Boring cannot originate a hole. Job is held in a chuck or face plate and a boring tool held on the tool post or fed into it. The operation is similar to external tanning in that the feed and depth of cut are given by the longitudinal and cross motions of the tool respectively. Counter boring. Process of boring a hole to more than one diameter on the same axis. Needed for receiving the head of the socket head caps carried out with a boring tool. Tapered boring is the process of making angular or tapered bores. Taping is the process of making internal threads by using a tool called tape. Milling is the operation of removing material from a workpiece with a multi-point rotating cutter, generally on milling machines. In the absence of milling machine, it can be performed on lathe by milling attachment. On a lathe, the milling cutter is held in the headstock and the workpiece is clamped in movable vise. Cutter is revolving against the workpiece. It is used for milling small workpieces only, where a milling machine cannot be used. Grinding is the removal of material by means of rotating abrasive wheel for finishing operations. Thread cutting on lathe machine by various cutting tools made of high-speed steel or often cemented carbide tools. Center lathes to single spindle automates are used. Special purpose lathes and CNC lathes including tanning centers are used. Threads are produced in center lathes by various methods, that is by single point cutting tool, by thread chasing, by attachments of die threading and tapping. Cutting with single point tool on lathe. A single point cutting tool is used to produce a thread form on a cylinder or cone. The tool moves linearly while the precision rotation of the workpiece determines the lead of the thread. The process can be done to create external or internal threads. Cutting with single point tool only. Operators should be fully conversant with different types, starts and shapes of threads. External or internal threads may be cut on lathe either with the help of a die or tape, respectively, or a thread cutting tool may be used. A certain relation is needed between job revolutions and revolutions of the lead screw to control the linear movement of the tool, parallel to the job length when half nut is engaged with the lead screw. The tool should be ground to proper shape and profile of the thread to be cut. The diagram indicates that cutting with single point tool on lathe, that is thread cutting. Cutting with single point tool on lathe. When cutting a screw thread, the tool is moved along the bed and is driven by a nut engaging with the lead screw. The lead screw is driven by a train of gears from the machine spindle. The gear train may be arranged in one of the following ways. Simple gear train, tans of lead screw divided by tans of spindle equal to teeth on driver A divided by teeth on driven B. It includes only 3 gears, driver, driven and some suitable intermediate gear. The intermediate gear has no effect on the ratio. It simply acts as a connection that is used to fill up the distance gap between the driver and the driven gear and makes the lead screw rotate in the same direction of the machine spindle. Cutting with single point tool on lathe. Compound gear train. Sometimes driver and driven gear ratio becomes so typical that the selection of gears to arrange in simple train becomes difficult. For example, driver and driven ratio is 4 divided by 26 and then a set of gears which can give this ratio in the simple train may become difficult. In such cases, the solution is obtained with the use of compound wheel train. The gear ratio becomes tans of lead screw divided by tans of spindle equal to teeth on C, which is indicated in the diagram, divided by teeth on D into teeth on E divided by teeth on F equal to teeth on drivers divided by teeth on driven. 2.5 mm pitch on a 6 mm lead screw. Drivers by driven equal to 2.5 divided by 6 equal to 5 by 12 equal to 25 by 60. 25 teeth driving 60 teeth in a simple train. These are some of the calculations pertaining to the gear screw thread operations. Cutting with single point tool on lathe, thread catching. Required depth of thread cannot be obtained in a single cut of tool and several successive cuts are needed. In the first cut, tool travels up to the job length and then it is to be taken to the starting position for giving the second cut. Now if tool is not fed exactly in the previous groove, it may form a new groove, thus wastage of the job. Modern machines are provided with facilities to reverse the rotation of job, which will bring the tool to original position without disengaging the half nut. But few machines are not equipped with such facilities. In those machines, tool is to be brought back by some other means. Cutting with single point tool on lathe, thread catching. At the end of each level of tool, take it back from the job surface and stop the machine. Disengage the half nut from lead screw and return it by hand to the starting point of the cut. By trial method, set the tool in right groove. Start the machine to have the first cut after giving a certain feed to the tool. Not disengage half nut from lead screw at the end of each cut. By reversing the direction of lead screw, bring the carriage to the starting position of the cut. A mark may be given on the bed by the side of the carriage. This will help in setting the carriage immediately. This method is useful for cutting threads on short lengths or in blind holes or for threads or odd pitches, which are difficult to cut even with the help of chasing dial method. Then procedure for external threads. Hold the job between the lathe centers or chuck as required and tan it to the size of the major diameter of thread to be cut. Select suitable change gear set for cutting requiring pitch of thread and arrange them. At the end of job, which will be starting end for every cut while threading, tan on a very small step of diameter equal to the minor diameter to be cut, that is SSE. Set the tool properly, swivel and clamp the compound rest at an angle if required as discussed already. Adjust the spindle speed for threading. Bring the tool at the starting point, take a certain depth of cut and engage the half nut with lead screw. This will move the tool along the job length, forming a threading groove. Hold the jaw in a check, make a hole equal to the minor diameter of the thread. This is the procedure for internal threads. A common practice is to make the hole slightly larger than minor diameter of thread for providing a clearance between the mating parts. Turn a small groove at the end of the thread length equal to the major diameter of the thread to guide the operator for maintaining the correct depth of thread. Cutting right hand threads. Direction of rotation of job and lead screw should be same, that is towards the operator. For threading on job, start the cut from tailstock side. After engaging half nut, see that the tool moves from the tailstock side to headstock side. Cutting left hand threads. Reverse the direction of rotation of lead screw with the direction reversing mechanism lever. Start the cut on job from headstock side so that when half nut is engaged, the tool should move from headstock to tailstock. Cutting multi-start threads. Compound rest is also used for adjusting the tool to have the correct spacing while cutting multi-start threads. Set the compound rest parallel to the work axis. When one start of the thread is cut, then the tool is moved a distance equal to the pitch to be cut. This method is mostly used for cutting internal threads. Make sure that there is no backlash in the compound rest screw. Tapered threads. The only precaution used for cutting threads on a tapered surface is that the threading tool is set perpendicular to the lathe axis and not to the tapered surface. Rest of procedure is same, only taper turning attachment is employed for taper turning and thread cutting. So these are the diagrams indicating the operation on lathe. In the first diagram, threading a V tool. Threading using a V tool is explained, and thread cutting is explained with the original motion taken by a photo. Typical lathe and components. So a lathe consists of feed selector, clutch, chip pan, apron, split nut, clutch, longitudinal and transverse feed control, feed rod, lead screw, bed, end wheel, tailstock assembly, tailstock wheel, dead center, base, carriage, cross slide, compound rest, tool post, spindle, headstock assembly and spindle speed selector. Bed is mounted on the legs of the lathe which are bolted to the floor. It is made of cast iron and its top surface is machined accurately and precisely. Cast iron passes are better lubricating properly due to presence of free graphite. It has high compressive strength, better shock absorption capacity. In order to increase its hardness and reduce the effect of residual stress, it can be easily alloyed with nickel. The diagrams indicate the cross section of the bed. Headstock is mounted permanently on the inner guideways at the left hand side of the leg bed. The headstock houses a hollow spindle to which bar stock can be fed and the mechanism for driving the spindle at multiple speeds. Using a chuck or collars, the spindle rotates the wheel. The spindle rotates on two large bearings housed on the headstock casting. Hole extends through the spindle so that a long bar stock may be passed through a hole. The front end of the spindle is threaded on which chucks, face plate, driving plate and catch plate are screwed. Tailstock fits on the inner face of the bed and can slide towards the headstock to fit the length of the workpiece. It is optional turning attachment can be mounted to it. It is equipped with a center that may be fixed. Carriage is located between the headstock and tailstock on the lathe bed base. It can be moved along the bed either towards or away from the headstock. It has several parts to support, move and control the cutting tool. Saddle is such-shaped casting. It connects the pair of bed guideways like a bridge. It fits over the bed and slides along the bed between headstock and tailstock. The saddle or the entire carriage can be moved by providing hand feed or automatic feed. Cross slide is situated on the saddle and slides on the dovetailed guideways at right angles to the bed guideways. It carries compound rest, compound slide and tool post. Cross slide hand wheel is rotated to move it at right angles to the lathe axis. Compound rest is a part which connects cross slide and compound slide. It has a circular base on which angular graduations are marked. The compound rest can be swiveled to the required angle by turning tapers. Tool post is located on top of the compound slide. It is used to hold the tools rigidly. Tools are selected according to the type of operation and mounted on the tool post and adjusted to a convenient working position. The diagram indicates the carriage. Lead screw is used and it is a long threaded shaft used as a master screw. It is brought into operation during thread cutting to move the carriage to a calculated distance. Mostly lead screws are Acme thread. Feed rod is placed parallel to the lead screw on the front side of the bed. It is a long shaft which has a keyway along its length. The power is transmitted from the spindle to the feed rod through tumbler gears and gear drive. The swing diameter over bed is a specification of a lathe, and it is explained as the largest diameter of work that will revolve without touching the bed and is twice the height of the center measured from the bed of the lathe. The length between centers is the maximum length of work that can be mounted between the lathe centers. The swing diameter over carriage is the largest diameter of work that will revolve over the lathe saddle and is always less than the swing diameter over bed. Next we will see about lathe classification and types. According to configuration, lathes are classified as horizontal and vertical. According to purpose of use, they are classified as general purpose, single purpose and special purpose lathes. According to size or capacity, lathes are classified as small or low duty, for which powers are up to 1.1 kilowatt, and for medium duty the power is up to 11 kilowatt, and large or heavy duty lathes are also used. Mini or micro lathe are tiny tabletop lathes used for extremely small size jobs and precision work. Example, Swiss type automatic lathe. According to degree of automation, lathes are classified as non-automatic lathes, semi-automatic lathes and automatic lathes. Semi-automatic lathes are nearly half of the handling operation, irrespective of the processing operations, are done automatically and rest manually. In automatic lathes, almost all the handling operations are done automatically. Example for automatic lathes are single spindle automat. According to type of automation, lathes are classified as fixed automation. Example is single spindle automat, Swiss type automatic lathe, etc. And flexible automation, modern lathes, example CNC lathe, training centers, etc. According to configuration of the jobs being handled, lathes are classified as board type, standard rod like jobs being held in collets, chucking type, disc type jobs being held in chucks, and housing type, odd shape jobs being held in faceplate. According to precision, ordinary lathes and precision lathes, these sophisticated lathes meant for high accuracy and finish are relatively more expensive. According to number of spindles, lathes are classified as single spindle and multi-spindle. Multi-spindle lathes are uncommon lathes and are suitably used for fast and mass production of small size and simple shape of the jobs. Types of lathes: bench lathe, speed lathe, engine lathe or center lathe, tool room lathe, capstan and turret lathe, automatic lathe, and special purpose lathe are some of the types of lathes. Bench lathe is very small lathe on bench or cabinet. It is used for small and precision work for light jobs and it is very accurate. Production of gadgets and punches etc. are done by using bench lathe. Speed lathes. In this lathe, spindle can rotate at a very high speed with the help of a variable speed motor built inside the headstock of lathe. Bench type, or you can have supporting legs cast and fitted to the bed. Most of the attachments like other lathe, but no provision for power feed. No gearbox, carriage and the lead screw. Tool is fed and actuated by hand. Engine lathe or center lathe, most widely used type of lathe, driven by steam engine past, so the name is engine lathe. Now driven by individual motor drive. Resembles a speed lathe, but its construction is relatively more robust. Its headstock is bigger in size and more robust, incorporating suitable mechanism for providing multiple speeds to the lathe spindle. The headstock spindle receives power from a lathe shaft or an individual motor through belts. In that case, it will have a cone pulley with back gears in the headstock to provide different speeds to the spindle. Tool room lathe. It is used for precision components, dies, tools, jigs, etc. Engine lathe equipped with some extra attachments for obtaining accuracy. Attachments provided are taper turning attachment, follow a rest, collets, chucks, etc. Capstan and turret lathe. In tanks, that is in war tanks, turrets refers to a sort of arrangement used to hold several weapons which can fire the particular shot depending on exact requirement. In ships, capstan is a spinning vertical cylinder used for pulling heavy objects with a rope. Semi-automatic and fitted with this multi-tool holding devices called capstan and turret heads. Different types of operation can be performed on our piece without resetting of work or tools in the capstan and turret lathe. Automatic lathe is used for enhancing the quality as well as the quantity of production. It is used for mass production of identical parts. All the working and job ending movements of job are automatic. No participation of operator is involved. Special purpose lathe example is gap bed lathe, which has a removable section in the bed in front of the headstock to provide a space or gap and is used to swing extra large diameter jobs. The wheel lathe is made for finishing the journals and turning the thread on railroad car and locomotive wheels. Some of the lathe tools are shown in the figures. Lathe accessories and attachments. Additional elements or devices essentially required for that machine's general functioning, mainly for properly holding and supporting the workpiece and the cutting tool. Centers, chucks, lathe knobs, drive plates, face plate, mandrels, steady and follow arrests are some of the additional attachments. Centers, there are two types of centers, that is live center and dead center. The center which fits into the headstock spindle and revolves with the work is called live center. The center which is used in tailstock spindle and does not revolve is called dead center. Chucks is an important device used for holding and rotating the workpiece in lathes. The workpieces which are too short to be held between centers are clamped in a chuck. Chuck may be divided as 3-jaw chuck or 4-jaw chuck depending upon the number of jaws used for holding the workpiece. Collet chuck used to hold smaller pieces. A collet is basically longitudinal split tapering bushing. The workpiece is placed inside the collet and the collet is pulled or pushed mechanically into the spindle. Other chucks are magnetic chucks, combination chucks, drill chucks for drills, and the air or hydraulic chuck. Drive plate, a circular plate which is bored out and threaded so that it can be attached to the spindle nose. It also carries a hole for the pin which is used only when this work is held in the lathe dog having straight tail. When bent tail dog is used, this pin is taken out and the bent portion of the tail is inserted into the hole. Face plate, similar to the drive plate but it is larger in diameter. It contains more open slots or T-slots so that bolts can be used to clamp the piece to the face of the plate. Angle plate. An angle plate is simply a cast iron plate with two faces planned at right angles to each other and having slots in various positions for the clamping bolts. Lathe dog or carrier. The work placed on a mantle or held between centers is rotated positively by clamping the dog or carrier to the end of the work. Mantles. Mantle or the lathe the mantle is a cylindrical bar with a center hole at each end. It is used to hold hollow pieces to machine their external surface. The diagram of mantles is shown in the figure. Then rests. Long workpiece often need to be supported in the mantle. Thus cutting tools can push the workpiece away from where the centers can support them, because cutting metal produces tremendous forces that tend to vibrate or even bend the workpiece. Steady rest and following rest are shown in the figure. In steady rest, log bolts, adjusting jaw, work hinge and binder bolt are some of the parts. Central lathe machine attachments. To perform some unusual or specific work, some special devices or systems are additionally used and mounted in the ordinary machine tools. Such additional special devices which augment the process capability of any ordinary machine tool are known as attachments. They are taper turning attachment, copy turning attachment, milling and cylindrical grinding attachment, grinding machine attachment for lathe, spherical turning attachments, relieving attachment, Thread pitch correction attachment for length are some of the attachments. Taper turning attachment. Cross slide is delinked from the center and is moved crossways by the guide block, which moves along the guide block pre-set at the desired taper angle. Thus, the cutting tool, which is fitted on the cross slide through the tool post in the compound slide, also moves along the taper to guide block in the same direction, resulting in the desired taper time. Mechanical type copy tightening attachment. The entire attachment is mounted on the saddle after removing the cross slide from that. The template reciprocating the job profile design is clamped at a suitable position on the bed. Hydraulic type copy tightening attachment. In mechanical system, the heavy cutting force is transmitted to the tip of the stylus, which causes vibration, large friction, and faster wear and tear. In hydraulic copying, where the stylus works simply as a valve, spooled against a light spring and is not affected by the cutting force. Hydraulic type copy tightening attachment. The cutting tool is rigidly fixed on the cross slide, which also acts as a valve and cylinder. If stylus remains on a straight edge parallel to the length bed, the cylinder does not move transversely and the tool causes straight turning. Milling attachment. This is a milling head comprising a motor, a small gearbox and a spindle to hold the milling cutter, mounted on the saddle after removing the cross slide, etc. Grinding attachment. Similar to milling attachment, grinding attachment has no gearbox and the spindle speed is much higher as needed for grinding operation. It is employed for external and internal cylindrical grinding, finishing, grooves, spines, etc. It cannot provide high accuracy in finish. It is called tool post grinder. Spherical or ball turning attachment. These simple attachments are used in center lathes for machining spherical, both convex and concave surfaces and similar surfaces. The desired path of the tool tip is controlled by the profile of the template, which is pre-made as per the radius of curvature required. This diagram indicates the spherical or ball turning attachment. Then relieving attachment. The teeth of farm relieving milling cutters like gear milling cutters, tabs, hops, etc. are provided with flank having Archimedean spiral curvature. Machining and grinding of such curved flanks of the teeth need relieving motion to the tool. Thread pitch correction attachment. While cutting a thread in the center lathe by single point chasing tool, often the actual pitch deviates from the desired pitch by an error, del P, due to some kinematic error in the lathe. Mathematically, Ps minus P suffix A equal to plus or minus del P. Therefore, for correct pitch, the error plus or minus del P need to be compensated, and this may be done by a special differential mechanism, namely correcting bar attachment, as symmetrically indicated in figure. Pa equal to 1 into U suffix C into L plus or minus del P equal to P suffix S tan plus or minus alpha into L divided by pi in Z, where U suffix C equal to transmission ratio, L equal to lead of the lead screw, M and Z equal to module and number of teeth of the gear fixed with the nut and is additionally rotated slightly by the movement of the rack along the bar. The thread pitch or correction attachment is shown in the figure. Thread chasing dial attachment. Thread chasing dial attachment is done in several passes. It is used for cutting threads and is done in several passes, and after each pass, tool is brought back to the initial start position for next pass. If the tool does not follow the path, the threads will be spoiled. The chasing dial overcomes the difficulty of catching the threads at correct start. It consists of graduated dial that is connected to a worm wheel. The worm is in mesh with the lead screw, so that if the saddle is stationary, the lead screw acts as a worm and rotates the chasing dial. Thread chasing dial attachment is shown in the figure. It consists of some parts such as dial, carriage, lead screw, worm gear and thread chasing dial. Eccentric turning attachment. It refers to the turning of certain diameters at different lengths on the same shaft or jobs whose axis is not falling in line with the main axis. A crankshaft of an engine is the example of such a job. So, turning mathematics is shown in this figure. Rough surface, shiny surface, rack face, tool, rack angle, flank face, relief or clearance angle, shear angle are shown. Tanning mathematics, material removal rate. The material removal rate in tanning is the volume of the material removed per unit time with the units of millimeter cube per minute. Thank you very much.